First of all, I would like to say good afternoon to the participants from China and the participants from Philippines and ISAAA. And I would also like to say good morning to the international expert from UK. And today I'm very pleased and honored to moderate the webinar, Global Impact of Biotech Crops, Economic and Environmental Effects, 1996 to 2018. Given the serious situation of COVID-19 spreading widely across the world, we are not able to organize an on-site meeting. Instead, we are holding such an online seminar. Today, we have 3 speakers to share their information or experience on biotech crops, of course, from different angles. Next, please allow me to briefly introduce the speakers in Chinese. 各位先生、各位朋友、各位女士，大家下午好。今天通过这样的一个网络视频会议，我们有幸邀请到了3位演讲者，与我们分享他们在生物技术植物、生物技术作物研发以及推广种植方面的信息以及经验。第一位演讲人是奥德米塔博士。奥德米塔博士呢是 ISAAA 的东南亚中心的主任，同时他也负责 ISAAA 的作物生物技术板块的业务。在过去的一些年中，奥德米塔博士主要是负责 ISAAA 每年1度的全球生物技术作物种植和商业化推广应用情况的报告书。那么同时，他也投入大量的精力在生物技术以及生物安全方面的能力建设。我们邀请到的第2位演讲者是来自英国的 Brookes 博士。Brookes 博士是一位农业经济学家，他在农业经济领域有超过30年的研究经验。那么在过去的一些年中，他为技术、政策、法规等等方面的制定提供了大量的卓有成效的咨询。自从上个世纪90年代开始，那么他也关注到农业生物技术领域的相关的研究，并进行了系统的经济学方面的研究。今天我们邀请到的第3位演讲人是来自中国河北省高碑店市的一位农民朋友，他名字叫祖茂堂，今年已经68岁了。从1995年开始，他就引进试种抗虫的转基因棉花，可以称得上是中国抗虫棉种植的第一人。所以今天借这样的一个网络视频的机会，他也非常乐意和我们各位共同分享他种植转基因作物的经验。按照会议日程，我们首先邀请第1位演讲嘉宾。Please, let's welcome Dr. Odemita to be on stage. Paula,
Yes.
please.
Yeah. Good afternoon. Good morning. And hello to everyone. Can you see my slides? Yes.
Yes.
Okay. So, okay, I'm just going to show you that. Okay. Currently, we have the global status of commercialized biotech GM crops has been published by ISAAA in the last 23 years. And as we are still putting together the 2019 data, I'd like to share with you the 2018 data, which would also be the data which will be used or based, where Dr. Graham Brookes will base his presentation and study. So the title of this brief is on biotech crops continue to help meet the challenges of increased population and climate change. And this is the reason why we have this webinar, because we want to show the global community that it is still is continuing with the data that Graham Brookes is going to present. So from 1996 to 2018, we have this global area, and which tells us that the area from 1996 to 2018 has been increasing. And in 2018, there were 191.7 million hectares planted to biotech crops all over the world in 26 countries. Now, 54% of this come from developing countries and 46% from industrial countries. And you see here that the developing countries has already made a tremendous increase by 2011, and it has been increasing, and it looks like in 2019, the same trend will be presented to you soon. Now, by trait, in the beginning, we have the herbicide tolerant soybean, which has increased tremendously, but we see here that it has been going down. And then the insect resistance in, in corn, in cotton has been increasing gradually, but the stock traits, which contains the insect resistance and herbicide tolerance, has been going up steadily. So these are the stock traits that can be found in corn, in cotton, and in soybean. So these are still an ongoing trend, and it looks like the stock traits is going up as expected because farmers are getting much wiser using stacked events in their planting and culturing our crops. Now, in terms of crop, biotech or GM soybean has been increasing, and see here that 50% of the global biotech crops is occupied by soybean. And then this is followed by corn, cotton, and canola. Now, the fluctuations in every year depends on the supply and, of course, the global price of the commodities. Now, looking at the 2018, or this is actually the data on the global area, the total global area coming from FAO in 2017 showed that 78% of all the soybeans planted globally is already biotech or GM. This is very interesting because we know that soybean is being used as soybean oil, as soybean crush products, for the feeds, and also for a lot of industrial purposes as well as food purposes. Now, 76% of the total cotton is already GM, and this comes for our clothing and also for industrial purposes. For maize, it's 30% of the global area is already GM, but there's still a lot of room to have GM in this space. So there were 197.2% of maize, and 30% of that is GM. For canola, 29% of the global area is already GM. And we are still looking at the data for 2019, and hopefully we can see that we would like to see that maize is going to at least move up in this way, going up. So this slide shows us the 26 countries that planted biotech crops. And you see here that there were 10 Latin American countries, 9 in the Asia Pacific, 2 North American, and 2 EU, and 3 African countries. Now, China is in the number 7, which planted 2.9 million hectares in 2018. Our new countries in 2018 were Indonesia and Eswatini, the Kingdom of Eswatini, or formerly Swaziland. Indonesia planted drought-tolerant sugarcane, and Eswatini planted BT cotton. Now, looking at the countries, we see that even if in the EU there were only 2 countries, African countries had 3. So we are optimistic that in 2019 this will be higher, because looking at our adoption rate, most of the top 5 countries already have a saturated adoption rate, meaning that they are very close to 100%. That's why our area, the global area, is now nearing to saturation or in a plateau. And this can only go up if we have more countries and more new crops being planted in globally. Okay, so one country at a time. We'll have US at 93%, Brazil, Argentina, Canada, and India. Now let's look at the approvals. ISAAA is maintaining the GM approval database. And from 1992 to 2018, we have seen 70 countries that have issued about 4,349 regulatory approvals. And this is increasing. We're collecting the data for 2019. And for that time, in 2018, we had 2,603 for food use. This number, 1,461 for feed use, and 825 for cultivation. USAA had the most number of approvals, about 544, and maize or corn had the largest number of approved events, which was 137 approved events in 35 countries. And then herbicide-tolerant maize events, NK603, had the most approvals of 61 approvals in 28 countries. So I invite you to look at our website, the ISAAA website, and locate the GM approval database so that you can see the current statistics on the approvals. Now, moving on to the contribution of biotech crops to food security, sustainability, and climate change, you can see here that this should be 2017. And these are the data from Graham Brookes from 1996 to 2017 that gave us indications that biotech crops have increased crop productivity, conserve biodiversity, provide better environment, reduce carbon dioxide emissions, and help alleviate poverty and hunger. So all this data will now be changed after the presentation of Graham Brookes, as we listen to him this time. So thank you very much, and would like to call in Graham Brookes for his presentation. Thank you.
Thank you very much, Ola. I think now is the time for polling. EJ, please share the poll questions now.
Host and panelists cannot vote.
Now, EJ, please show the results of the poll question. What is that?
Do you want me to start?
Yeah, so what is the noise?
Okay, it's gone.
Okay. So, is it okay for us to continue the webinar?
Yes, please.
Okay. Now, please, Dr. Graham Brookes, it's your turn to present.
Okay. Good afternoon, ladies and gentlemen. I'd like to thank ISAAA and CropLife China for inviting me to present to you today. As Ola said in her earlier presentation, I am essentially going to update the information on the analysis we regularly undertake on the global impact of biotech crops globally to cover the period 1996 to 2018. This is now the 14th annual review of global GM crop impacts that we have undertaken, and during this period since 2004, when we started doing this analysis, we have now written and authored more than 30 papers on the impact of this crop technology in peer-reviewed journals. And the latest two papers, one covering economic impacts and one covering environmental impacts, are now available at the journal GM Crops and Food on the link that you can see on this slide. These papers are available on open access and are therefore freely available to anyone to download. There is no charge for that. For those of you who want an even longer, more detailed pieces of information, they can be found in the full report, which is more than 200 pages in length, on our website at the address shown. The analysis I'm going to present to you covers the period to 2018. It will cover farm income and productivity impacts on things like farm income, yield and production, the environmental impact associated with changes in pesticide usage, and the environmental impact associated with greenhouse gas emissions. The methodology, or how we have undertaken the work. We have reviewed and used a considerable amount of impact literature that is in peer-reviewed journals. After more than 20 years of using this technology, there is now a lot of analysis in peer-reviewed journals. This forms the main basis of our analysis, but because there is not impact literature covering every trait in every country in every year, we have also undertaken some of our own analysis. We use current price, exchange rate and yield information and update important costs of production each year to ensure that our analysis is as dynamic and up to date as possible. We've reviewed pesticide usage information where it's available. And we use an indicator called the Environmental Impact Quotient, which was developed at Cornell University in the 1990s. This is an indicator which is improved in terms of looking at the impact on the environment compared to just looking at changes in the amount of a pesticide used. It is still a fairly crude and simplified measure, but we consider it nevertheless to be an improvement over just using amount of active ingredient applied. And lastly, we reviewed literature on carbon impacts, mostly associated with changes in fuel use and soil carbon changes, but I will explain these in more detail during the presentation. Let me start by providing you with the overview information. During the period to 2018, on the crop area that is used biotechnology, pesticide usage on that area has reduced by 776 million kilograms, which is equal to an 8.6% reduction in the amount of active ingredient applied. But more significantly, if you use the EIQ indicator, it is a larger 19% reduction in the associated environmental impact. In terms of farm income impacts, the farmers who've used the technology have increased their income by $225 billion in extra farm income, mainly through increased yields. Global production of the four main crops of cotton, maize, soybeans, and canola, there's been an extra 824 million tons of these crops produced in the world that wouldn't otherwise have been produced. And the technology has been responsible for reducing the amount of carbon dioxide emitted into the atmosphere, and the 2018 figures show that the amount of CO2 reduced from release into the atmosphere has been equal to taking the equivalent of 15.3 million cars off the road for a year. If we focus on the 2018 figures, the total farm income benefit in 2018 was $19 billion. That's equal to adding 5.8% to the value of the global production of those four main crops. In terms of the cumulative amount of farm income gain, as I said earlier, it's equal to $225 billion. If you want to put that in the context of a per hectare gain, it's nearly $100 per hectare, $97. And that income share between farmers in developing versus developed countries shows that 52% of all those gains during that period have been to farmers in developing countries and 48% to farmers in developed countries. If you then look at the breakdown of the average farm income gains by country, this slide gives you that breakdown, and you can see that the highest income gains per hectare have tended to be in developing countries and mostly associated with the adoption of biotech cotton. You'll see China at the top of that, although I will speak more specifically about China a little later on. In terms of the distribution of the farm income gains around the countries, you'll see that the United States at 41%, as farmers in the United States have been the main or the largest recipients of farm income gains. And that is not surprising, given that the United States was where the technology was first widely adopted. And for much of the last 20 years, the adoption rate of biotech in those four main crops has been over 90%. You will also see other important adopting countries where farmers have got substantial gains, such as Brazil and Argentina in South America, and related to the adoption of biotech cotton in India and China. I put this slide up to also highlight that there are other reasons other than just farm income gains as to why the technology is popular with farmers. For example, the herbicide tolerant crop technology, one of the main reasons farmers like this technology, because it's increased their flexibility or the convenience in how they manage their farms. It has helped many farmers go into and stay in using no tillage practices. Again, I will talk further about this later in the presentation. Insect resistant crops, one of the main benefits that farmers often talk about is how it reduces their production risk. For example, they don't have to worry so much about whether a particular pest is damaging or eating its way through their crop. It's also improved the quality of crops that farmers grow. For example, maize, less damage from corn boring pests, improves the quality of the grain and less wastage. And also, especially in a crop like cotton, which has traditionally been sprayed many times with insecticides, the reduced number of applications means less exposure of farmers, especially in developing countries where often they are making limited usage of protective clothing and equipment, means less exposure to such products. If we then move on to making a comparison between the overall benefits of the technology and what share goes to farmers and what share goes to the supply chain that provides the seed to them. So it's not just the technology providers, but the seed companies, the farmers who multiply the seeds. You can see that overall, that the technology cost the equivalent of 27% of the technology benefit. So in other words, for every extra dollar that farmers invested in biotech seed, they got an average of $3.75 in extra farm income. So in other words, a very substantial return on their investment. And for farmers in developing countries, the return on investment has been even greater at $4.42 in extra farm income for every extra dollar they've invested in seed. In terms of the comparison to where the savings are coming from, nearly 3/4 of the farm income gain has come from yield improvements, with the remaining gains coming from reductions in costs. Very broadly, the yield gains have mainly come from the insect resistant technology, and the cost savings have mostly come from the herbicide tolerant technology. And the yield gains have tended to be greatest in developing countries, and the cost savings mainly found in the developed countries. If you then move on to looking at some of the specific crops in terms of the yield improvements, insect resistant maize. Across all the countries that have used the technology, the average yield gain has been more than 16%. The highest yield gains, again, have been found in developing countries like the Philippines, Colombia, Honduras. Similarly, if you look at cotton, average yield gain nearly 14%, the highest yield gains found in developing countries. Insect-resistant soybeans been available in South America since 2013, average yield gain of 9.5%. Most of that technology has been used in Brazil and to a lesser extent in the other 3 countries shown. In relation to the herbicide tolerant traits, there's also been examples where farmers have got higher yields, most of that associated with improved weed control. And this slide summarizes where farmers have obtained higher yields associated with the adoption of the herbicide tolerant technology in different crops. If you were to then add up that extra yield that farmers have got and put it in the production equivalent terms, this slide shows you that during the period 1996 to 2018, the world has had nearly 500 million tons extra maize produced because of the use of crop biotech, and nearly 278 million tons of extra soybeans, nearly 33 million tons more cotton lint, and 14.1 million tons more canola. If you were then to look at that extra production from a different perspective and say, if this technology had not been used and that amount of extra production had to come from conventional agriculture, this slide gives you the equivalent for 2018 of what extra conventional crop area would be required to have produced that extra production. And you can see it comes to, in 2018, just over 24 million hectares of extra conventional cropping that would have been required. To give you context, that is equal to 38% of the cropping area of Brazil. I mentioned earlier the insect resistant technology and the adoption of cotton in China. This slide gives you the overview of the impacts of insect resistant cotton, which has now been used in China for well over 20 years, an adoption of 95%, an average yield impact of about 10%, a very impressive average farm income gain of $366 in extra farm income per hectare. In terms of the average return on investment, this is also very impressive in that for every extra dollar Chinese cotton farmers have spent on the Biotech seed, their return has been $7.9 of extra farm income. So a very high level of return on their investment. And it is therefore not surprising that the technology has been very popular amongst cotton farmers in China, as demonstrated by the high level of adoption. Over the period, these figures should say 2018, not 2016, show $23.2 billion worth of extra farm income and an extra 7.9 million tons of cotton lint. Moving on to pesticide use impact. As I said earlier, since 1996, the use of pesticides has fallen by 776 million kilograms, or 8.6% decrease in the amount of pesticide active ingredient used. To give you some context, that is roughly equal to about 1.6 times the amount of pesticide active ingredient applied to crops in China. In terms of the EIQ indicator, the impact is larger at a 19% reduction in the EIQ load. The largest environmental gains have come from the adoption of insect-resistant cotton, with the amount of insecticide use falling by nearly a third and the EIQ impact indicator falling by a larger 35%. The environmental gains from the use of insect-resistant cotton in China have been very similar to the global figures, in the sense that there has been a 139 million kilogram reduction in insecticide use, nearly a third, and similarly a 32% reduction in the associated environmental impact as measured by the EIQ indicator. Moving on to greenhouse gas emissions. Crop biotechnology has contributed to reducing greenhouse gas emissions from two main sources. Firstly, reduced fuel use from less spraying of crops and less ploughing or cultivation of land. The herbicide tolerant technology has also facilitated and helped many farmers, especially in North and South America, to go into and adopt no-tillage production systems. Now, when you move to a no-tillage system, you are no longer ploughing the land and therefore releasing carbon in the soil that is coming from decaying plant matter. So you are leading to additional soil carbon storage because you are no longer ploughing. And that is actually the single largest source of greenhouse gas emissions that comes from arable crop production. Looking at the 2018 figures, the impact of using crop biotech has resulted in fuel usage from less spraying and less tillage falling by 2.4 billion kilograms less CO2 released into the atmosphere. But the facilitation of carbon saving from additional soil carbon storage is 20.6 billion kilograms of CO2 not released into the atmosphere. So a total of 23 billion kilograms saving, or equivalent to taking nearly half of the cars registered in the United Kingdom off the road for 1 year. Moving on to looking at potential negatives associated with the technology, given that I have highlighted a whole string of positives from adoption of the technology. Well, the one that often is raised as the main potential negative has been with the use of the herbicide tolerant technology and over-reliance on glyphosate by some farmers in North and South America has contributed to weed-resistant problems, and farmers have therefore had to adapt and change their weed control systems, which has resulted in increases in herbicide use and higher costs compared with the situation they were faced with 15 years ago. However, this needs to be put in context because weed-resistant problems and increasing herbicide use is also a trend that is equally applicable to conventional crops. In fact, the initial adoption of herbicide-tolerant crops, especially in a crop like soybeans in North America in the mid-1990s, was actually making a major contribution to addressing problems of weed resistance to herbicides in conventional agriculture. So weed resistance issues are equally applicable in conventional crops, and tracking the changes in the amount of herbicide use and the costs of weed control in conventional crops during the last 20 years shows that whilst there have been increases in both the amount of herbicide used and the cost of a production with herbicide tolerant technology crops, this has equally been applicable to the conventional alternative crops. And in fact, if you look at in North America, the rate of increase in herbicide use and associated costs on the conventional crop equivalent has actually been slightly higher than on the herbicide tolerant crops. Also, the environmental profile of the herbicides used with the GM herbicide tolerant crops has continued to be better than the equivalent on the conventional crops. And the herbicide tolerant crops have continued to remain more profitable than the conventional alternatives, as demonstrated by the fact that the adoption levels have not fallen below 90% in many of the cases where the technology has been used. Returning to my earlier slide, just to put this up for you, for all the viewers today, this slide again just highlights the summary figures that I have already presented in my presentation. Moving on to concluding comments, in sum, the insect resistant technology is mainly delivered for farmers higher yields, less production risk, and a reduction in the amount of insecticide use. And farmers have got higher incomes and the world has had a more reliable food supply, and farmers are using a more environmentally friendly farming methods. The herbicide tolerant technology has delivered similar impacts, higher incomes, extra production, but it's also facilitated and helped many farmers adopt no tillage production systems, but more importantly, stay in no tillage production systems. And this has made an important contribution to reducing greenhouse gas emissions. Both the insect resistant and herbicide tolerant technology have made important contributions to increasing world production of those 4 crops, which has contributed to reducing pressure to bring new land into agriculture. And in the last 2 or 3 years, we're also now beginning to see newer traits come forward, such as drought tolerant maize, fungal resistant potatoes in the United States, and insect resistant brinjal in Bangladesh. Moving on to my last slide, on the basis of our analysis, this shows that after 23 years of widespread use, crop biotech has demonstrated that there is a considerable body of consistent evidence now in peer review literature on the impact of the technology. And this analysis I presented to you today, which is available in 2 new papers, adds to that literature. I again highlight the link that you can go to download these copies. And I would take the opportunity to encourage all of you to read these papers and delve further into the references cited and draw your own conclusions. For those of you, finally, who may want to obtain a copy of my presentation, this is available at the end, and there is also a Chinese language version available to you as well. Thank you for your attention, and I look forward to answering any questions that people may have later in the session. Thank you.
Yes, thank you very much, Doctor. Thank you for sharing all those data regarding the economic and the environmental effects by adoption of biotech crops. Thank you. 下面让我们欢迎祖茂堂先生来与我们分享他种植转基因作物的经验。
我看一下，
声音稍微大一点点。
行，好，
我可以说话了吗？
可以了，您说，您说。
张所长，主持人，
你好，祖先生。
你好，张所长。你好。
你好，请开始。
哎，好的，我这边可以说了。
可以说了，开始就行。
大家下午好，我是河北省高碑店市人，我叫祖茂堂。我跟大伙儿啊，跟各位朋友说说，我种植抗虫棉的经历，也叫做是抗虫棉种植历程。我要说的题目呢，就是关于我们的农田。我还是从2010年说吧。2010年呢，那时候我种的抗虫棉什么品种呢？一个是银棉1号，是河北省审定的品种，和那个抗虫棉的3系杂交抗虫棉。杂交抗虫棉产量高啊，那因为它是杂交种嘛。 这2个品种呢，一共种了164亩，那年的收入呢达到了16.2万元，收益非常好，效益非常高。我很高兴。回忆起来呀，没有转基因抗虫棉之前呢，我们的生活品质都下降了。因为棉花是经济作物，经济作物是我们棉农的钱袋子，是吧？我们要花钱就从棉花上找。97年以前呢，我们种的都是普通棉花，不是转基因的抗虫棉，不是没有种过转基因抗虫棉。90年代初啊，也就是90年、93年，棉铃虫啊大爆发。棉花对这些个农药啊都产生抗药性了，老打药。特别是刚才我说了，90年代初的时候，小小的一个棉铃虫啊，把我们搞的是谈虫色变。一说到棉铃虫，大家都害怕，怕到什么呢？这种它太厉害了，像新精虫一样。到处除了电杆子不吃，什么都吃。它是棉花上面的第一主要大害虫。这样一来啊，给我们棉花也种不了，没收成，这个也没钱花，生活上面当然就很困难了。记得那些个年呢，特别是到了7月份、8月份，3代棉铃虫是最厉害的。那时候啊，我和我爱人呢，就整天不离棉花地，出去喷药，然后呢，早晨呢，老早就得起大早，赶紧上地里捉虫子去。它那个3代棉铃虫又抗药性特别强，因为你打不死。你说都讲究是叫做上边盖顶，全身喷透，但是你怎么喷透，它的棉铃虫不死。特别是30的，20以前的还好消灭。药费呢，算起来啊，这1年的药费得有150块钱左右，而且打的次数呢，每次打药都得差不多10块钱。这样算下来呢，1亩地的农药呢，得1亩地得打一次得10多块钱，喷个13、14次、15次都有。这是药费方面开支，打药这方面开销就挺大的。你说农药是假的，是吧？农药跟虫子那个什么，它由于它产生抗药性了，药喷在虫子身上它又不死。有的那个早青啊捉出来的那个幼虫，你放在农药里边它还游泳呢，还浮游泳呢，它也不死，你药都药不死。可是呢，你这样的虫子，比方说人拿出来为了鸡吃了，照样中毒。你说是有毒是没毒啊？你说农药是管用是不管用啊？对宠物不管用，可对这个什么都管用，对这个你要是扔在地下，鸡吃了都管用。一个小小的棉铃虫啊，把我们都搞的是这个狼狈不堪呐，又打药，定得烈日是吧？下午，都说虫子吧，天气最热的时候打药效果好，大卖场的就去喷药，这样一来啊，就是好多就是中毒的。再一个就是吧，好多打药，我这说一个啊，就是呋喃丹。呋喃丹本来是治的地下害虫的这种农药，结果人们都发现，把它泡了水，沁体液拿出来灌在药桶子里去喷，一喷棉铃虫死。可是这个你要烈日之下喷那种剧毒农药是吧？那种剧毒农药对人的就是说中毒，要中毒很深的话，那会死人的。那个呋喃丹呢，当时是管性有效果，但是呢，它是这种中了毒没法救，就发生了死人事件。所以说，真正的我们是非常苦恼。我再形容当时那个棉花啊，由于那个棉花你打药没治住虫子，打那么多也治不住怎么着？有的那个棉花吧，由于它 生吃生长没有，就是没结桃子，光是长了个秧在那儿的。一说我们这地方一般的都70-80公分高，那个棉花应该正常高度是70-80公分，不超1米高。结果呢，有的1米5、6。我一像我这个个儿进去之后，都得手摸着才能够得着。老百姓管它叫公棉花，因为它没结棉花桃嘛，没有棉花。当时这个就是一般的来说有产量的，也就是30-50斤。我记得最清楚的有一家伙，1亩地只合4公斤，也就是80斤棉花。你说可怜到什么程度啊？就等于是绝收差不多，费了半天，投了半天资，打了半天药，费了半天劲，还差点还有生命危险。这样呢，你说那个当时生活困难不困难？我刚才说了，你种棉花就是我们的钱袋子，你哪儿来钱花？没有钱花。下边我就要说了啊，97年，中国批准了这个种植转基因抗虫棉了，这发生了天翻地覆的变化，有了抗虫棉。抗虫棉的产量是原来这个普通棉花的增产了10倍，也就是说呢，原来平均40-50斤产量，现在呢，紫棉呢可以收500斤紫棉。当然了，这效益也提高了10倍，还不光10倍，后来棉花又涨价，是吧？转基因棉花确实给我们带来了很好的经济效益，我们是笑逐颜开呀。主要是体现在我们生活有了钱了，我们的生活品质肯定要提高的。当时啊，那个价钱呢，就是2.5块到2.8块，后来吧就涨到了2.5块。当时的紫棉，2010年的时候，秋季的时候从地里摘了，那就6块多钱。你可想而知，还不至于我上面说的这几个数字。当时我就算了，除去成本吧，赚个400-500块钱，那是手拿把攥的问题。没有亲临棉田的是体会不到的。据了解啊，据我知道的是吧，我想也提一下，从97年转基因抗虫棉呢开始应用，到2016年的时候，我国呀，国内的抗虫棉呢种到了95%，总面积的95%，产量呢也提高了10%。另外还了解到啊，这个到2016年的时候，由于抗虫棉的种植，中国的这种棉农吧，我们这些棉农总收入增加了是1567亿人民币，相当于美元的是232亿，平均每公顷，咱们说公顷啊，不太是什么，不太顺是吧？1公顷是15亩地，也就是说呢，每15亩地收入增加了呢是2470元人民币，相当于折成美元呢是366美元。再一个就是呢，我要跟大伙儿分享一下呢，2010年的时候11月份，我受欧盟议会生物技术产业协会，这个协会的邀请，参加了比利时召开的世界农业技术产业协会 农民活动项目。在会上呢，我发言时呢，讲了讲咱们中国呀农业生物技术的应用这种现状，以及自己啊种植抗虫棉的体会。另外呢，我还再说一下，就是2010年的4月份呢，至2010年的10月份，受中国农业科学院生物所的委托，到巴基斯坦呢，旁遮普省种子公司把中国的双价抗虫棉这个基因呢导入到当地的主栽棉花品种当中。我们棉农啊，期待农业生物技术产品，期待农业生物技术的新技术。随着中国农业生物技术迅猛发展，我们已经享受着和正在享受着实实在在的转基因的好处。我们棉农也好，粮农也好，都是渴望着有更好的、更多的生物技术产品，对人类有利的这样的基因，好的基因呢，给我们中国的农民带来更好的经济效益和社会效益。我这种期盼呢，我觉得好多农民和我都有同感。我们真诚的希望啊，农业生物技术新的技术、新的产品应用于到我们农业的实践当中，发挥上很好的经济效益，对我们农民的生活品质有所提高，对我们的农民生产有所帮助。我就和大家分享这些，谢谢大家。
好的，祖先生，非常感谢您和我们分享您的精彩的人生故事，再次感谢。
谢谢
Now,
大家。
okay, so now it's time for another polling time. EG, please share the poll question now.
Okay.
Okay, so EG, please show the results of the poll question.
I think that's it.
Yeah. Thank you. It's well done. Thank you very much. Now, let's move on to the discussion session. So actually, I have received some questions from the participants. The first question is for Graham. The question is, what is the impact of the COVID-19 on global biotechnology? How long will the impact last?
I think my swift answer to that is I have no idea.
Yes.
The only thing I can say is COVID-19 will and has disrupted food production and food supply, but because food production is essential, my personal perspective appears that the world food production and distribution has held up very well to date, but I can't comment further on it.
Okay, so thank you. And we have got another question. How to address the issue of residue of glyphosate being found in some crops? How to address the issue of residue of glyphosate being found in some crops?
Well, there are two or three things I'd say. Is firstly, I'm an agricultural economist. I am not a scientist who is an expert in that field.
Mm-hmm.
Secondly, as far as I am aware, glyphosate as an active ingredient breaks down in the environment very quickly and more quickly than many other products, and therefore the amount of any residue that may exist in a crop that is ultimately consumed is likely to be very low and invariably within the safety limits that are required in all countries. So I wasn't aware that glyphosate residues is a particular problem anywhere in the world. But as I said, I am not an expert in that field. And maybe somebody else on the panel may have more relevant information to respond to that question than I can.
Okay, thank you. Regarding this particular question, Ola, do you have any clue about this?
Yeah, actually, glyphosate is considered as a very safe herbicide. And so whatever residue is found in the leaves or in the crops or in the fruits themselves, they have been degraded immediately after, not immediately, but 3 days after, and it's not going to stay there for quite some time. And it is degraded into a very non-harmful component, degraded as in it's not active anymore. So it has already done its job for the weeds around the crops, and when it is in the fruits, it is degraded easily, and glyphosate is considered as class E or class F, which is the most non-hazardous herbicide in the world. And you can check that in the international websites where herbicides are recorded on their harmfulness or their lethality to people, to crops, and to animals. Thank you.
Okay, so thank you very much. 下一个问题，是给那个提给祖先生的。祖老师你在吗？在的。 这个问题是，请问祖老师，
啊。
对于除了棉花之外的其他作物，比如玉米呀、小麦啊等等，这些作物的转基因品种，在中国的发展有什么建议？
呃，我想是这样的，我也挺简单，就是说呢，只要是，我认为这个基因呢，是吧？好多有的搞不清楚是什么作用，或者对人呢究竟有没有害，是吧？只要是对咱们这个要说起来啊，就是对于咱们这个人类没有危害，是吧？只有好处，是吧？那何乐而不为啊？再一个就是，你说的刚才是玉米、小麦是吧？在中国发展有什么见？这些个，你比方说玉米上边的那个最大害虫就是一个玉米钻心虫，也叫玉米螟，是吧？小麦上主要害虫一个是西江虫，一个是蚜虫，蚜虫最厉害。你比如说想法把这个蚜虫啊怎么能够控制在不用防治、不用打药的这比例上就行。你比方说5%以下是吧？百株率都不需要治，控制在这个范围，我觉着就比较好。有这样的基因当然是好了，是吧？但是呢，必须是说这个基因是安全的。当然，这些个科学家们，我想不会说是研究出对人体有害的基因来，是吧？我还是相信科学家，这个科学精神，是吧？但是说这个研究出这样的，肯定对农民有好处，农民肯定是欢迎的。我想说这么多，我也不知道完整不完整，反正我觉得就是首先是这个基因呢是安全的，是吧？有田间技术，包括一些个实验都证明是没有害，是吧？只有好处。你看抗虫棉这么成功，推的这么成功是什么？是吧？那是一个很好的中国成功的一个事例。我想今后的这个粮食方面呢，这个如果有好像这个抗玉米螟的，我就说的是钻心虫，来个就是那个小麦上面的蚜虫，能给控制了，那好的，可以减少好多农药，可以提高作物的品质。我想还是农民肯定是欢迎。我就说这么两句吧。
好的，祖老师，下面还有一个问题，可能问您比较合适。这个问题是说，呃，抗虫棉在中国已经种植很多年了，
对对对。
目前是否有发现，棉铃虫对，这问题应该是这样的，它原话是说是否有发现对棉铃虫的抗性？我的理解呢，它的意思本意可能是这些这个棉铃虫是否已经出现了对抗虫棉的抗性？我的理解应该是这样子。然后这个接下来是农民种植时是否有被要求考虑，延缓这些抗性产生的一些种植方式，比如也同时种植这个庇护所，就是种一块非转基因的这个棉花。这个问题，祖老师能回答吗？
能回答，我觉
好，
得我能回答。
嗯。
中国抗虫棉在中国种了这么多年了，在抗虫棉呢也产生了很好的社会效益、经济效益。要说到农民种棉花、种抗虫棉花，是不是延缓？到现在来说也没发现过这个棉铃虫啊，棉铃虫就是考虑到延缓抗性种植方法。我想是这样的，主要是这个转基因棉花 BT 基因呐，这个你也得不断的，我叫做从那个什么上育种上边说的，应该是提升复状，保持啊它这个抗性的在这棉株里边的这个那个什么吧， 表达能力。你比方说，从这个抗虫里选抗虫性更强的品种呢，就可以那个有效的说，刚才就是说那个延缓呐、什么种植方式，那就不存在了。主要是我觉得抗虫应该搞好这个基因的保持它的那里边的那叫什么呀？我就说是表达的特别好的那个，你不就是抗性特别强的，把那选下来，然后每年利用就行了。这是一个。再一个就是那个种植庇护所呀，种植庇护所是我感觉没有必要。它这个棉铃虫是杂食性的，它那个什么也吃，它那个就是花生叶子照样吃，不是说这单一的棉花上边它危害棉花，那么它就不能繁殖后代了啊，那就是生态平衡，我觉得不会受到影响。就是一个棉花上边不至于让它受到说这个棉铃虫就绝了种了，我觉得不会，生态平衡是没问题的。
OK， 好，谢谢左老师。Okay, sorry, I forgot to translate this question that was raised for Mr. Zhu. The question was, the BT cotton has been already planted many years in China. At the present, has ever been found that the pest has already developed a sort of tolerance to the BT cotton, and there's any way, for example, the refugee strategy can be useful to delay the production of the tolerance of the pesticide of the pest to the transgenic BT cotton. So that was the question. Now the next question is still for Graham. So the question was, is there any difference of environmental impacts on developing countries and developed countries? The cultivation style or model could be different between the US, Brazil, and the APAC countries. Graham, please.
Yes, the answer to that is both yes and no. There are similarities and differences. Generally, traditionally, the amount of agrochemicals used in developed countries tended to be higher in the developed countries than in developing countries, and therefore when the technology was used, a lot of farmers in developed countries obtained most of the benefits associated with reduced cost of production from using less insecticides or less or cheaper herbicides. But nevertheless, there have been some similarities in developing countries, even though the basis of production may be different, in the sense that a lot of production in, say, the United States are on large farms, whereas a lot of the production in developing countries are small farms of less than 1 hectare in size. But in developing countries, especially in a crop like cotton, where your average size of farm is very small, often below 1 hectare, the main change, there still have been substantial changes in cost savings from reduced insecticide use. And my other speaker, who gave his very personal story of experience of using BT cotton in China, is a fine example of how his farming practices have changed with using the technology in significantly reducing the amount of insecticide that he has used. Also, on the herbicide tolerant crop area, you have seen in developed countries, you've had changes in the profile of weed control from using specific herbicides to more generic broad spectrum herbicides like glyphosate. And in some of the developing countries where, for example, biotech corn has been used in the Philippines or in Vietnam, you've had a move away from similarly using a number of specific herbicides to glyphosate, but also a move away from farmers using hand weeding to the use of glyphosate. So that's been one other aspect of difference between the two. So there have been some similarities and some differences, and it does tend to vary by crop.
Okay, so thank you very much. Meanwhile, we've already received some questions from the WeChat broadcasting platform. So apparently, Graham, you are the webinar star already, because this question is still raised for you. The question was, Dr. Graham, do you have any study or estimate about the economic and environmental impact of the newly approved GE soybean and corn traits in China?
Well, my analysis goes up to 2018, and it does not have any analysis of such new trait adoption in China. And as an analyst, I would love to be able to identify information on levels of adoption and impact, because I am sure there must be people in Chinese research institutes and universities who are at this very moment looking into potential impacts of these new traits. And I hope to be able to obtain and talk to people who may be collecting that type of information.
Okay, so thank you. While due to the time limit, we will take the last question.
No,
From the
Chun-Yi,
audience, and
we can go. We can continue till 4:45.
Okay.
There are
Okay.
still a lot of questions, so it's okay.
Okay, yeah. So this question is also received from the WeChat broadcasting platform, which is raised for you, Ola. The question was, since the GM crops have been largely adopted in developed countries, especially in what? NA, what does that mean? What does USA? And almost saturated.
North America. I think it's North America.
North America,
okay.
yes.
And almost saturated. Therefore, the adoption of GM crops in developing countries, for example, APEC countries, could contribute to further increasing global adoption of GM crops in future. What kind of traits or crops do you think are very promising?
Currently, that's what I said. The reason why we're having a plateau at this time is that most of the big developed or industrialized countries are now nearing saturation. So I said most of the countries that are not planting yet should start planting, and that new traits should come out. So currently we're happy that there are new traits, just like drought tolerance, insect resistance in soybean, new crops, just like potato, and yeah, sugarcane is also a new crop. We're still waiting for safflower to start being planted by different countries for a source of oil. And yes, more developing countries are now gearing up on their planting of biotech crops. And we will see that in the 2019 report, as I see that reports that come in show that more developing countries are going to be featured in the report, in the new report. Thank you.
Okay. Now, another question, maybe for the whole panel, or especially for Ola or Graham. The question was what about the acceptance level of GM food in European countries now? Yeah, because around 10 years ago, there were lots of media coverage on harmful effects of GM food in European countries. So can you say something, Graham?
Are you
Yes,
going to
I could
start?
talk about
Okay.
this. I could talk about this all day. The situation in Europe now is the levels of citizen understanding and acceptance is better than it was 10 years ago. So we're starting from that base. Consumer knowledge of biotech crops, though, is, however, still badly misinformed from a lot of misinformation that was provided by people who were against using the technology from many years ago. And as a result, you have very small areas of biotech crops grown in the European Union, mainly one trait insect-resistant maize in Spain and Portugal. And that is the only trait that's been approved for planting. However, the consumption of foods derived from or containing GM ingredients is very substantial. For example, the European Union annually imports about 39 million tons equivalent of soybeans in the form of soybeans or soya meal, mostly for use in animal feed. As Ola's presentation showed, 3/4 of the world's soybeans are genetically modified, and 95% of all soybeans and meal traded on global markets are genetically modified. So out of the European Union's imports of soybeans and soya meal, the vast majority of them are genetically modified. So almost all livestock production that uses soybean ingredients, which is mostly poultry, egg production, and to a lesser extent in dairy and pig production, will be using feed ingredients derived from GM crops. So it's important to look at the difference between, even though Europe doesn't grow GM crops, it is still using and consuming a large volume of them.
Okay, so thank you very much. Well, actually, the next question is still for Graham, but I think this question is largely related to the question you just answered. Anyway, I'm reading it. Do you have any data or comments about the relationship between the GM crop acceptance in the European countries and the economic importance of agriculture in those countries. So the relationship between the GM crop acceptance and the economic importance of agriculture.
I'm not exactly 100% sure I am following the nature of the question, but I would say that the European Union has not allowed its farmers access to this technology, but it has effectively allowed the importation and use of crops and ingredients used in the feed industry that are derived from the technology. So in effect, it is chosen policies which are hindering the competitiveness of its own farmers, not only in their own European Union markets, but when they wish to export their products onto global markets. So by adopting a policy which restricts access to new technology, such as crop biotech, the European Union has effectively hindered its own farmers' competitiveness. That would only be a sensible policy if there was a very large market that wanted products that were certified to be not using genetic modification. However, that market, whilst it exists, is very small, and most European farmers, where they have to compete with imported produce, will find that they are losing out from a competitive perspective.
Okay, so thank you. Ola, actually, we have got some questions from the participants, in particular regarding the biosafety of biotech crops. For example, there's a question asking, there are many people worried about the safety of GM foods. For instance, it may pose threats to the next generation. So what do you think?
Actually, this question has been there for quite a while, even before the commercialization of the first biotech crops. But we saw that in the last 23 years or 24 years, there has been no lethal incidents that happened because of biotech crops. So because all of the biotech crops that are commercialized pass through a very thorough assessment following an international standard, which is the Codex Alimentarius. And this has been going on for more than, yes, as I said, more than 24 years. And it is assured that the biotech crops in the market are safe. Now, there has not been any recorded incidents on deaths or any hazardous effects on humans and animals. So it is considered safe. Thank you.
Okay, so thank you. Well, any more questions from the participants? Because we still have some time.
Can we ask our panelists to give a short summary or takeaway messages?
Yeah.
Can you ask Mr. Zhu first.
OK。祖老师。
你好。
OK。
这个您简单的谈一谈从参加这次这个研讨会，这个从几位演讲人的报告当中，以及从刚才的回答问题互动的过程当中，您最想带走的信息是什么？您感受最深的是什么？
就是生物技术啊，生物产品呢，这个叫做最前沿的科研成果，应用到咱们的农业生产方面啊，人们生活当中呢，我觉得是一个非常好的这个事物吧，叫做是吧？这个我想给大伙儿捎回什么信息呢？包括我周边的农民朋友啊，农民兄弟，是吧？都是种地的，都是祖祖辈辈在那儿种地。想跟大伙儿啊传递一种什么信息？就是说啊，咱们这转基因呢，确实是个好东西。绝对不是说那个哎就是抱有持疑怀疑那个怀疑态度的人呢，应该正确认识转基因产品、转基因技术。这个还需要啊，我想还需要这个通过这次网络会吧，我想有好多数据在说明转基因确实是个好产品，确实是个最前沿的农业生产上面的特别需要的技术。再一个就是我们农民呢，这个需要这些个。
Hello, I can't hear you anymore. 我听不到了。
I think we've lost him.
I think, has he finished his thoughts?
No, I don't think so.
I think we've
祖
lost
老
him.
师，你还在吗？
Do you want me to say something?
祖老师，你还在吗？
Okay, maybe if
Okay, I will. Okay, I will translate a little bit. While Mr. Zhu emphasized that the biotechnology is very, very important for the life of common people like him, as well as for the social and economic development in a country. And the message he would like to take away is that he will say to his friends or colleagues that the biotechnology is a good thing, and the biotech crop is a good product. We all need the edge-cutting technology like the biotech in the future.
yeah, that's correct.
Okay, I think we lost him. Yes.
Yeah. Okay.
So, any comments from you, Ola, or Graham, or other panelists?
Graham can go first.
You want me to go now?
Yes, okay.
I'm just picking up on the chat list. I think we may have not fully answered one of the questions first, and there was there was a question that was asking about GM crop production and requirements for quality food and natural biodiversity. And I think it would be valuable for me to emphasize a couple of points here that that came from my presentation, that the adoption of the technology, notably insect-resistant corn, has led to improved quality of maize. So it's actually contributed to better quality food, because by controlling corn-boring pests, it has reduced the damage to maize crops and the buildup of cancer-causing mycotoxins in the grains. So it has reduced the levels of exposure to these health-damaging problems where maize is consumed directly by people in countries such as Honduras, and or resulted in less rejection of maize by food companies. Secondly, on the biodiversity issue, I referred to the point about the extra production of soybeans, maize, cotton and canola that has arisen from the higher yielding biotech crops. And that extra production in terms of conventional crop equivalents is reducing the pressure to bring in new land into agriculture. The best biodiversity found in the world comes from land that is not in agriculture. Therefore, the technology, by reducing the pressure to bring in new land into agriculture, is making an important contribution to maintaining biodiversity, natural biodiversity around the world. And I put up in my slide saying that in 2018, the extra production, if it had to be produced on conventional agriculture, was 24 million hectares. And I gave the equivalent land, arable land in Brazil. To give you the Chinese perspective, that 24 million hectares is roughly equal to about 16% of the cropping area in China. So one of the take-home messages I would identify is the technology has delivered economic benefits from improved incomes to the farmers who've used it, but it's importantly delivering vital environmental benefits in terms of reducing pressure on new land to come into agriculture, which will be bad for biodiversity, and is improving the global environment by reducing greenhouse gas emissions, which, as we're all aware of, is vital if the world is to adequately address climate change problems. Thank you.
Okay, so thank you. Actually, regarding the quality improvement, I would like to add something. We know that sorghum is largely consumed in some of the African countries. However, there is a problem for the protein digestibility. Therefore, we can do something to adopt a sort of biotechnology to increase the digestibility of the proteins in the sorghum. Therefore, the people can gain better quality of sorghum grains. That's what I want to see. And
Thank you.
Ola, please.
Yes, actually, I'm very happy with all the questions that came up and the discussions that we had. We are still strongly supporting Biotech crops. We saw the contributions to all the economic benefits to all of us, the livelihood, the economic effects, the health issues, because we know a lot of Biotech crops already have those certain traits that has omega-3 fatty acids, or we now have some kinds of oils in soybean and in canola that will help the human population. Also, as what Graham said, there are a lot of crops now which can be used by livestock, because wastage is already has declined because of the absence of those toxin producing microorganisms in crops, because there are no more holes in all our crops, especially in corn. So there are many advantages of Biotech crops, and acceptance is key to gaining the benefits of these Biotech crops. And one of the things that we have to look into is how do we capacitate ourselves, on how do we make the people in our own country or in China to accept Biotech crops, the benefits, and the changes that will happen in our lives. I think that's my last talk. Thank you.
Okay, so thank you. Any other comments from the panel?
Yeah.
No.
Okay, so thank you. I think while time flies, we are now approaching the end of the webinar. So the last, I would like to welcome the ISAAA Global Coordinator, Dr. Arujanan, to give us the closing remarks. Dr. Arujanan, please.
Dr. Chingy, thank you so much. And on behalf of ISAAA, I would like to thank China Biotechnology Information Center, who is part of ISAAA network, for hosting this webinar. Thank you also to CropLife China and Dr. Chongi yourself for your support. And of course, our esteemed speakers, Dr. Graham Brookes, a longtime partner of ISAAA, for sharing your data, and our farmer was so impressive on the global status of commercialized biotech crops. Dr. Brookes' data on social economic impact of biotech crops helps many key stakeholders around the world to make informed decisions on approval and adoption of biotech crops. And that is why ISAAA took up this initiative to make sure that the data is disseminated to all those who are involved in this area. And Mr. Tu, you really touched our hearts, telling us how farmers contribute and what are the challenges you face. Now, China is a key economy in the world. We are all looking up to you for your innovation and futuristic technologies. We are all amazed with your 5G technology and now eager to hear about your 6G. When many countries were still at infancy in GM technologies, you developed your cotton. We are still watching you for your leadership in agriculture and new breeding technologies, or NBT. Dr. Brookes' data clearly shows the socio-economic benefits of biotech crops. The new tools are now going to open even more doors, especially to developing countries, as more public sectors will now be able to develop and commercialize new crops and traits. This is very important because we want to develop crops based on our own priority. And it will also boost public-private collaboration. NBTs will also create technopreneurs among our young graduates. Both GM technology and NBT, together with conventional breeding techniques, will all serve to job creation and, more importantly, ensuring all this is done sustainably without a lot of damage to the environment. I personally think it's not just about feeding the world. It's not just about food availability or food security, just one component of food security. Our newer challenges are getting young farmers to take up agriculture as a profession and nutrient security. Dr. Graham's data clearly shows GM technology no longer ignore. And our farmer, Mr. Chu, also affirmed this. Looking at all these positive data, both from Dr. And also in supporting developing countries to embrace gene technologies for crop development. We will continue with our outreach programs and capacity building programs, and even coming up with new approaches. I'm wishing China all the best, and please continue to inspire us. We need a leader among the developing countries for innovation in agriculture. Now, my last message is for the critics of GM technologies. Please speak to the farmers before speaking for them. Crops to be developed, approved, and adopted. Let us listen to them and support them. With that, thank you very much. And thank you, everyone. Thank you for the active participation and very good discussion.
Thank you. So that's it. Let's see, we see each other next time, either on the line or on site. Okay.
Okay. Thank you, Chunyi.
Okay,
Okay.
bye-bye.
Thank
Bye-bye.
you. You did a good job. Yes. Thank
Bye-bye.
you. Bye-bye. Bye-bye, Graham. Bye, Maha.
Bye.
Bye, Mr. Zhu.